Welcome to this video on the normal curve. Okay, so if you're going to get data on the normal curve, also known as the normal distribution or the bell-shaped curve, they're going to give you information beforehand. So they're going to tell you that data in a certain set forms a normal distribution or bell-shaped curve. So they're going to give you, sorry about that. They're going to give you that data. They're also going to give you the mean. In a normal distribution, once they give you the mean, you have also figured out the mode and the median, because in a normal distribution, the three M's, the measures of central tendency, are all identical. So technically, they could give you the mode, and you should be able to figure out the mean, because that number is always going to be the same. And the third thing they're going to give you is the standard deviation. Okay? Also, if they tell you it's a normal curve and they give you data, just from that data being graphed on a polygon, you should be able to figure out the mean and the standard deviation by looking at the graph. So that's another way to do it. Okay, so if you see a bell-shaped curve with data, you should be able to do this and this just by looking at the graph and the numbers that are on that graph. Okay, let's take a look at some things about the normal curve that you need to know in addition to these facts. This just needs to be memorized. Data in a normal curve. The data in a normal curve falls within certain set percentages that are connected to the standard deviations. Remember, that's the variations from the mean. So when we graph this, I want you to imagine the y-axis is here, right? So when we graph our data, and this will usually be given to you, I want you to imagine this like a mountain. You always know that the very top of the mountain when we're dealing with polygons is the mode, right? That's the score that occurs the most frequently. Therefore, it's going to be the highest, right? You also know that that is the mean and the median when you're dealing with a normal distribution. That is not the case when you're dealing with a skewed distribution. Okay, so the mean would go here. Okay, this represents one standard deviation above the mean. And one standard deviation above the mean, the percentage of scores that will fall there is always 34%. Okay? Some books will have the percentage with the decimal 34.13. You don't really need to know that. 34% of the scores will always fall one standard deviation below the mean. The mean is here, okay, represented by that 0 for now. And then basically, when the data says, or when they ask you, what percentage of the scores fall within one standard deviation, they mean plus or minus 1. So you would add 34 and 34, and you would get 68. So 68% of the scores fall within one standard deviation, which means plus and minus 1. One below and one above. Two standard deviations, which would mean plus 2 or minus 2, 95% of our scores fall between there. Okay? Because the percentage between here and here will always be 13.5% of our scores. This will always be 13.5% of our scores. So to get this 95, you just add 13.5 and 34 plus 34 plus 13.5, and you get your 95. What this is trying to say is that the vast majority of scores are clustered around the mean. That's what makes the normal curve, is that the majority of scores are close or clustered close to the mean. All right, so most of the scores are distributed. The normal distribution, most of them are distributed close to the mean. So these percentages will always stay. Now, I think your book has this one as 0.1 and this one as 0.1. It doesn't really make a difference, all right? Don't worry about that. But again, you have to memorize these percentages connected to these standard deviations on the bottom of the polygon. Okay, let's take a look at another way they might ask you questions on this. So they might give you a graph here. We know that this forms a bell curve, right? This is the symbol for mean. This is the symbol for standard deviation. Remember, you can pause me at any time. So what I'd like you to do is, I'd like you to tell me what the mean is. I would also like you to tell me what the standard deviation for this data set is, for this normal distribution. And remember, the y-axis is just there. Okay? All right. So you should have figured out that the mean is 52 because the mean and the mode and the median are all the same. They're at the top of the mountain, right? Right over here. Now, this is the first score above 52, and this is the first score below 52, right? So we're within the realm of one standard deviation below the mean, one standard deviation above the mean, right? So what would be the standard deviation? Well, what is 58 minus 52? It is 6, right? So the standard deviation is 6. 52 minus 6 is 46. So that is the standard deviation for this. Now, another question they might ask is, what percentage of scores will be between a 58 and a 64? What percentages of scores will be between a 58 and a 64? So let's just shade that in right here. We know there's a 34% here. 34% of the scores will fall between a 46 and a 52. We know 34% will fall between a 52 and a 58. We know that between 40 and 46, 13.5, and we know between a 58 and a 64, 13.5% of the scores will fall. So that means the answer to this question is 13.5% of the scores will fall between a 58 and a 64. If you were asked what percentages of scores will fall between a 40, right, and a 64. So what is the answer for that? So again, you would add 13.5, 34, 34, and your 13.5. And that would give us 95% of the scores will fall between a 40 and a 64. So again, it all comes back to having to memorize these percentages. These are your standard deviations. This will always be the same. If it's a normal distribution, this setup will always be, and you'll be able to plug any scores into them. Okay, so let's do one more. Let's just change this, right? Let's change this, and let's say the mean is 100, and let's say the standard deviation is 20. So again, I want you to put me on pause, and I want you to do this yourself and then come back. All right, welcome back. So this would be 100, this would be 120, this would be 140, this would be 160, this would be 80, this would be 60, and this would be 40. Okay? That's as simple as it goes. It doesn't matter if I said that the mean was, if I told you it forms a normal curve, and I told you the mean was 75, and the standard deviation was 5, basically the 75 would go here, 80 would go here, 85, and 90. And in this direction, you would subtract 5, right? And that's it. It really is as simple as that. You simply have to memorize this data.